Since we have learned all the equations of the plane, we're going to talk about relationship between line and plane first. Okay, there will be three relationships that we're talking about. Okay, number one, if you can see from the diagram, the line is actually parallel to the plane and the line lies on the plane. Okay, second diagram you see is that the line is parallel to the plane, however, the line doesn't lie on the plane. So under these two portions, you can see that the line and plane are parallel. Then the third kind of relationship is where the line and the plane are not parallel. They will definitely intersect at a point. They will intersect at exactly one point. So first, we're going to learn how to determine the relationship. And also in this portion, we're going to try to find the intersection between the line and plane. Okay, so let's talk about how do I determine first. Okay, step number one, I have to determine if the line is parallel to the plane. Okay, let's talk about how do I determine if line is parallel to the plane. So let's say this is my plane equation. This r dot n equal to alpha being a constant. So my n is over here. And let's say this is my line equation. Okay, we're going to assume that the line doesn't lie on the plane first. Okay, for plane equation we are using normal. For the line we are using direction. Okay, you can see that the line and the normal is actually perpendicular to each other. Okay, and to determine if they are perpendicular, I just simply have to take the normal and the direction, dot with them. If I get 0, it means that line and the plane is parallel. Okay, so I take n, dot with my d, see whether it's equal to 0 or not. Okay, if it's equal to 0 means the normal and the direction is perpendicular, hence the line and plane will be parallel if it's equal to 0. Okay, all these are in layman terms, so I'm going to teach you how to present using the examples, and we're going to determine how to actually find out if the line lies on the plane or the line does not lie on the plane. Okay, let's look at example 1 quickly. Line direction is given to you, or rather line equation is given to you, and the plane equation is given to you. So first step, I'm going to take 2, 3, 1, 2 minus 3 and 1, dot with my 1, 1 and 1. Essentially, you should get 2 minus 3 plus 1, which gives me 0. So you can quickly say that the line and the plane are parallel. Next, I want to take note, okay, for line equation, I have a point here and I have my direction. Okay, same thing, I have a point here and I have my direction. Okay, if the line and the plane are parallel and the point on the line lies on the plane as well, okay, then it means that the line will lie on the plane. If the point does not lie on the plane, however, the line and the plane are parallel, then it just simply means that we are at the second scenario where the line is just simply parallel to the plane and does not lie on the plane. So how do I determine? Okay, I'm going to take the point over here, which is on the line, which is 103. So 103 is the point that lies on the line, to dot with my 1, 1 and 1. Okay, essentially you should see that I get 1 plus 0 plus 3, which gives me 4. Okay, and we learn from scalar product of a plane, if I take any point and dot with my normal and get the constant at the back, it simply means that 103 will lie on the plane. And because the point that lies on the line lies on the plane as well, and the line and the plane are parallel, I can quickly derive that the line lies on the plane. Okay, and line and plane are parallel. Okay, so that's how we actually determine if the line is parallel to the plane and whether the line lies on the plane or not. Okay, so let's quickly do up part B. Okay, so same thing. Okay, for plane equation, let me change it to normal for easier verification. Equal to 10. Okay, so from here, same thing, I'm going to check whether the line and the plane are parallel first. So I'm going to take the direction of the line, which is 2 minus 3, 1, dot with 1, 1, 1. I should get 2 minus 3 plus 1, which gives me 0. So I can immediately say that the line and plane are parallel. Okay, from here, what I'm going to do is, I'm going to check if the line lies on the plane or the line does not lie on the plane. So from here, I'm going to take the point, which is 1, 0, 3, dot with my normal, 1, 1, 1. I'll get 1 plus 0 plus 3, which gives me 4. And this is not equal to 10, where 10 is from your equation of your plane here. Okay, since it's not equal to 10, I can say that, okay, point 103 does not lie on the line. Hence, the line and plane are parallel, but line does not lie on the plane. Okay, that's how we actually determine for part B. Okay, part C, okay, I have actually created the plane equation out, the scalar product of the plane equation. You should be able to do it very quickly since we already learned how to do it. Okay, if you do not know how to do it, please kindly refer back to the old video or the previous part video. Okay, so let's talk about part C. Okay, so first thing first, as usual, we're going to determine if the line is parallel to the plane. So I'm going to take the 2, minus 3 and 1, dot with 1, 1 and minus 1. Okay, which is the direction of the line and the normal of the plane. I should get 2 minus 3 minus 1, which gives me minus 2 and not equal to 0. Hence, I can say that the line and plane are not parallel. Okay, so we're going to learn how to actually find the point of intersection between the line and plane. Take note of this concept because we will be using this concept later on in the further parts of planes. Okay, so I'm going to quickly just draw out. This is my plane equation. R dot 1, 1 minus 1 equal to 1. And this is my line. R equal to 1, 0, 3 plus lambda 2 minus 3, 1. Okay, I'm going to let the point P be the point intersection. So we're going to let P be the point of intersection, okay, between the line and plane. Okay, take note, point P will lies on the line and it also lies on the plane. That's why they are the intersection. Okay, or rather point P is the intersection. So since I can quickly say that from here, since P lies on the line, OP is equal to 1 plus 2 lambda minus 3 lambda and 3 plus lambda 4. Some lambda is real number. Okay, and I can also say that since P also lies on the plane, okay, we learn from the scalar product of the plane. Okay, 1 plus 2 lambda minus 3 lambda, 3 plus lambda, which is my OP. Dot with my normal, 1, 1 minus 1, I should get 1, since OP will lies on the plane. Okay, so I just quickly expand out. 1 plus 2 lambda minus 3 lambda minus 3 minus lambda should give me 1. Okay, so a quick expansion or simplification, I will get minus 2 lambda, which is equal to 3. Okay, so lambda will be equal to minus 3 over 2. Okay, then once I get this value, I'm going to quickly sub back to my OP. Okay, so OP will then be equal to 1 plus 2 bracket minus 3 over 2 and minus 3 times 3 over minus 3 over 2, and last one is 3 plus 3 over 2. Okay, further simplification, I should get minus 2, 9 over 2, and the last one will be 9 over 2. Okay, so this is my OP equation. So if you want to write down in coordinate form, it will be essentially this. Okay, so this is how we actually find the point of intersection of a between the line and the plane. Okay, so I can say that, okay, if you want to conclude the relationship, I can say that, okay, the line and plane intersect at point P minus 2, 9 over 2 and 9 over 2.